Hi students, welcome to my engineering graphics class. I am Dr. Vinodkumar, adjunct professor in Cochin University of Science and Technology, Kerala. In this video, development of surfaces 2, we discuss about the development of cylinders. I have got a cylinder 50 mm diameter, 60 mm axis, standing on its base on HP, or you can say 70 mm axis, standing on its base on HP. I have drawn the plan and elevation. I have taken 12 generators on the surface of the cylinder. We recall that in projection of solids as well as in section of solids, we have taken 12 generators on the surface of the cylinder. It's extremely essential. Okay. A, B, C, D, E, F, G, H, I, J, K, L are the points of the base. M, N, Q, R, S, T, U, V, W, X, Y, Z are the points of the top. OP I have spared for the axis. I have not marked the axis here. Okay. A dash to L dash in the elevation on the base. M dash to Z dash on the top. Now, you know what is development. Development is unfolding of the paper wrapped around the surface. Isn't it? If you take only the sides, you say development of lateral surface. And if you add the top and bottom, you say total development. If you assume you are wrapping a paper around a cylinder and take out that paper, what is its shape? Its shape is going to be a rectangle. What's the length? Length is equal to pi d, circumference, perimeter of the circle. And what's the height? Height is equal to the cylinder height, axis height. Agreed? Now, let us draw the total development of the cylinder. There are two options. First option is start with a point A, calculate pi d circumference, calculate pi d and get another point A, then complete the rectangle and divide it into 12 equal parts following the procedure of dividing a line. This line is to be divided into 12 equal parts following the procedure of dividing the line. That is the best option. The second option is, if you are taking 12 generators, the second option is take a starting point, take this code in your divider, put it on another code, verify, again verify, ensure that it is correct, place it 12 times on this line and then complete the rectangle. There will be a difference of 1 to maximum 2 mm. 1 mm will be sufficient. If you are sufficiently careful, the divider which you use must be the one which is moved with the help of the thread. Engineering instrument box, the divider present in the engineering instrument box is used for that purpose. If you use the divider seen in school instrument box, like the one what is usually used nowadays, you won't get it correctly. There is an engineering instrument box in which there is a small divider which can be moved by rotating a wheel. Once you fix it, it will not change. So that divider has to be used. Or there is a small compass also, similar compass which can be moved by rotating a wheel, which is moved with the help of a thread, fine thread, on which you can set a distance permanently, it won't change. So if you use such instruments, you can go for it. So it is completely left to your choice which method to adopt. Agreed? I am completing the rectangle. I am completing the rectangle and dividing it into 12 equal parts. When you do it, you can use the method which is most convenient to you. And I reproduce those generators here, very light. Don't draw very dark. I don't say very light, reasonably light. It's all decided by your pencil and your attitude, isn't it? If you want your drawing to be good and neat, you have to apply your mind into the drawing. A, B, C, D, E, F, G, H, I, J, K, L, A, M, N, Q, R, S, T, U, V, W, X, Y, Z, M. You have drawn the plan and derivation. Now I am going to draw the base. I draw it at D. You are free to draw it anywhere. I prefer to draw it at D. So that this is C, this is B, this is A, E, F, G, H, I, J, K, L. You have to take the 12 points on the circumference. I draw this at some other point. Say W. I am drawing it like this to make you understand the options. That's the top, this is the base. Okay. Now, this can be cut by different types of cutting planes and the changes that occur in the development can be shown. If this is the cylinder, this is its development, full development. Agreed? Now, if it is cut, corresponding changes will come in this. Let us consider the first cutting plane, which is extremely easy. VT. How many generators cut? It cut all the 12 generators. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Draw a horizontal line here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. Remove the top, keep the bottom. For that, what you do? Darken these lines. Darkening these lines indicate that the whatever is darkened is remaining, whatever is kept light is removed. Okay. Darken these lines to indicate that this part is kept. This is the first cutting plane, which is extremely simple. Okay. I spent more time on the second type of cutting plane. Second cut. Where is the second cutting plane? The second cutting plane is 40 degrees to HP. The question is clearly given in your description. On this video, the description given in the video will contain the detailed question. The question says the second cutting plane is horizontal. The second cutting plane is horizontal. When second cutting plane is making 40 degrees to HP and it bisects the axis. The first cutting plane which I have already drawn is horizontal and which give very negligible change in the drawing. This is the second cutting plane. Bisects the axis and passes at an angle of, making an angle of 40 degrees to XY line. VT. 40 degrees to HP. How many generators it cut? All the 12 generators. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. What do you keep? The portion below the cutting plane, you can dark it. To draw the development, draw a light horizontal line through 1 dash. Very light. 1. Extend it further, very light. 1. Another line through 2. 2. Extend it further. 12. Then 3. Extend it further. 11. 4. 10, 5, 9, 6, 8, and then finally 7. Connect them by a smooth curve because the surface of the cylinder is smooth and when it is cut you will get a smooth curve. Connect them with a smooth curve. This is the development of the cut portion of the cylinder. This is a full portion. Once you draw the cutting plane, darken the portion below the cutting plane, the top is removed. As we will assume the top is removed. This sort of cutting planes or cylinders are important in pipe joints. When you join pipes, this sort of cutting planes become very important. This is the second cutting plane. I am going to draw the third cutting plane also in this. Where is the third cutting plane? third cutting plane passes through a point on the axis VT. Point on the axis 45 mm both the ways. Both the ways, making 40 degrees to HP. This was the previous cutting plane, 30. Now, where does it cut? Let us examine. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Then on the top, 6 dash, 7 dash. Then again here at 5 dash, 8 dash, 9 dash, 10 dash, 11 dash. I repeat, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash. Where is 1? 1 is on AM. Draw a horizontal line through 1. And also here, another 1. 2 is on BN. 2. In line with it, you have got 12, 11. 3. 10. 4. 9. 5. 8. What about 6 and 7? If you draw a horizontal line through 6 and 7, it coincide. You cannot go like that. Drop it down. Drop 6 dash 7 dash down to the plan. You get 6 on ST and 7 on VI. 6 on ST and 7 on VW. When you drop it down, you can see 6, 7. On the way from S to T, this is S to T. On the way from S to T, there is a point called 6. How do you take it? Take S6. Here the distance between S and 6. In a small divider and mark it. You get 6 on this S6 also. ST also you have to mark 6. On the way from V to W, 7. On the way from V to W, 7. On the way from V to W, 7. Connect this 6 and 7 by a straight line. And here 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. I repeat, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. And in the next case, when the cutting plane is inclined to VP by an angle passing through 10 mm away from VP, axis, inclined to VP by 50 degrees and 10 mm away from the axis, what do? You have drawn similar cases in sectional solids. Draw a 50 degree line anywhere on XY line, draw a 10 mm radius arc, then parallel to this line and tangential to the arc, draw the cutting plane, HT. Where does it cut? Cut the base at 1, top at 2, top at 3, base at 4. This will be removed, isn't it? 1, 2, 3, 4. If you project the elevation, 1 will give you 1 dash, 2 dash, 3 will give you 3 dash, 4 dash. 1 dash, 2 dash, 3 dash, 4 dash is a rectangle, you can hatch it, that is in sectional view. Here we are not going to draw the sectional view, we directly transfer these points to the development. One is on the way from C to D. Take the small distance C1 and mark between C and D, 1. Between C and D, 1. Same is the distance of 2. 2 is on QR, 2. QR, 2. Then 4 is on GH, 4. GH, 4. Take the small distance in your divider and mark GH, 4. UV, 3. UV, 3. GH, 4. Connect 1, 4 by a straight line. Connect 2, 3 by a straight line. Connect 1, 2, 3, 4 by straight lines. 1, 2, 3, 4. 1, 4, 2, 3. Which is removed? This portion is removed. That means which contains D, E, F, G are removed. D, E, F, G are removed. This is inside this boundary is removed. The dot outside is darker. This is darker. This is light. This is light. This is darker. This small portion. This small portion are removed. So this completes the 4 types of cutting planes that are extremely important in cylinders. I told you somewhere cylinder development of cylinder is important in pipe fittings and ducts, air conditioning ducts and other fluid ducts use this concept very widely. Very simple questions. Cylinder, section of cylinder is important also. Thank you.